Well, hello everyone, and welcome to this Mobile World Live webinar that we are running as part of our themed week program for October. I'm Justin Springham, and I'm delighted to be your moderator for today's event. Today's webinar is brought to you with our partner HAPSMobile, and will examine how high-altitude platform stations, known as HAPS, have the potential to connect a large proportion of the world's population that still do not have access to the internet. We'll be providing a lot of information in this webinar. The aim is that in the next 45 minutes, you'll better understand what HAPS is, its progress so far, the opportunities ahead, and how operators can benefit from the technology. So let's kick things off with some introductions. I'm joined today by two expert guests.
Justin, thank you very much for the introduction. Again, my name is Hide Kitahara. I'm the head of Global Business Strategy Division at the SoftBank Corporation, and also I'm the board member of HAPSMobile. I'm very pleased to be here. It's midnight here in Japan, but I'm really happy to be here and share our vision and a mission and then what we would like to do for next 10 to 20 years. So, first of all, we like you to watch the movie. Through these movies, you will see, HAPSMobile missions and the vision overall.
Throughout history, we have ventured into new territories. We have reached and explored outer space, but not the stratosphere. In 2017, SoftBank established HAPSMobile and set off on a journey to the stratosphere. For what purpose? For the Internet. With the widespread expansion of mobile devices, we now use the Internet whenever and wherever we like. But half of the world still does not have access to the Internet. So, for the future, HAPSMobile will take up the challenge of building a stratospheric telecommunication platform system, HAPS. HAPS is an unmanned aircraft system equipped with a mobile base station. It uses solar power to fly in the stratosphere. With this aircraft transmitting radio waves from 20 kilometers up in the sky, it can cover an area with a diameter of 200 kilometers. This coverage is equivalent to about 400 base station towers on land. HAPS's big advantage is that people can use the mobile devices that they normally use. Along with smartphones, HAPS can even be used for low-priced and energy-efficient IoT chipsets. Unlike satellite communications that require dedicated equipment, existing 5G and LTE can be used as is. With today's communication infrastructure, there is no internet where there are no people. But there are IoT devices, observation sensors, and cameras that are waiting to be connected. Imagine this: a future with HAPS aircraft flying above us, covering wide areas, resistant to disasters. The internet is a core infrastructure, just like water, gas, and electricity. We're on a mission to make the technology accessible for everyone. We will continue to take on the challenge of developing the future of mobile communications to deliver internet connectivity across the entire world.
So I hope you captured the mission of the HAPSMobile and what we are trying to do. But let me jump into our vision. So we have two big visions within HAPSMobile. First one is to eliminate this divide from the global market. Unconnected. 4 billion people unconnected in the world. So people who haven't touched the internet, people haven't sent the email or SMS over the smartphone or the phones, cellular phones. So our target, our vision is to make those number 4 billion to 0 in 2030X. It's not easy work. It's going to take a long time. So we are expecting to happen in next 10 to 20 years. But this is our mission. We're going to make unconnected people to connected. So another mission is we're going to move our communication to next generations. So, all the networks in the world are based on the people. Our network design is based on the people. So, for example, all the MNO talks about what is the population coverage, 70%, 80%, 90%, 100%, because all that network is designed for the people. But from now on, we have to have a coverage for the things. For those areas who doesn't people live, for those area people doesn't go, but things are there. We need to have a coverage. In next 5 to 10 years, drivers will not drive the car. It's gonna be autonomous. Everything will be autonomous. In that case, the car has to be monitored, and there are many places, for example, like a super rural area, there may not be a connection or connectivity. But in the autonomous driving era, you gotta have the monitoring system from the remote over the air. You need to have the connectivity. So with the HAPS, you can connect via the HAPS. Drones can be connected via the HAPS. So this is just an example of the Japan. For the 3G and 4G, population coverage in Japan is almost close to 100%. It's a 99.9%. So you can have a connectivity, you can do the communication anywhere, anytime, wherever you want, even in deep door, wherever. However, if you look at the land coverage wise, it's only 70%. Population coverage, again, it's 100%, but land coverage is only 70% in Japan. And I think this is going to be the same situation for the other countries as well. So what is the solution? Again, it's a HAPS. It can cover 200 kilometer diameter, which is equal to 400 base stations. If you are the MNO operators, you can imagine how much it's going to cost, how many kilometers of the fiber you have to have the 400 base stations on the ground. But with the one aircraft HAPS, you can cover 200 kilometer diameter. But we are not saying that HAPS is going to replace every single base station on the ground. HAPS is going to work with the base station on the ground, so we call hybrid. So HAPS mobile base station is going to communicate with the base station on the ground, and it's going to cooperate. So wherever you can find a signal from the ground base station, it does directly communicate with the base station on the ground. But if there's no area or if there's no signal from the ground, the mobile phone directly communicate with the HAPS signal. That's how it works. And to HAPS work, you need to have two links. One is the feeder link. So you need to have a ground gateway, which is connected to the fiber on the ground. And that communicate with the HAPS aircraft. And HAPS aircraft is going to have the couple of the sectors. And that couple of the sectors is going to make the big diameter, which is 200 kilometers. And another unique thing about HAPS is, again, you do not need to have the special device. It's a mobile direct communication so that you can use the regular phone like an iPhone or Android phone that you're using every day. But with a satellite, if you compare it with a satellite device communication, you need to have a special terminal, special CPE to communicate through the satellite. And usually that satellite device is very expensive and it's very big. So compared with HAPSMobile versus satellite, from the user perspective, the device-wise, you do not need to have the special device. That's the big benefit. And another unique thing is HAPSMobile doesn't use any oil or gasoline. It's 100% clean energies. So as you can see on the wing, we install the solar panel. So at the daytime, it's driven by the solar panel. And then at the nighttime, it's driven by the batteries. So it can fly, of course, 24 hours, and it can fly for several months. And we are targeting for half year so that you can have the, stable connectivity service through the hubs. And another unique case is disaster recovery. When the base station on the ground is something happen or failures, and it cannot do the communication, HAPS still can provide a connectivity service through the aircraft if the ground station still alive. So like a typhoon, earthquake, those kind of season or the kind of event happens. When it happens, HAPS can help the people for the connectivity service. And another use case is again like a 3D expansion area. It's a vertical way, not only horizontal way. So vertical way, like in next 5 to 10 years, drone will be very common, or flying taxi will be very common. But as I said, ground base station is like 30 meter to 40 meter above the ground. So usually it doesn't cover the high area. So with the HAPSMobile, it can cover the high altitude. And it does create a new business, like a drone or a flying taxi. It's going to be the necessary and then a very basement for those business areas. So I would like you to watch another movie about the service concept.
HAPS is a mobile direct communication system in which an aircraft delivers telecommunication network connectivity, such as LTE or 5G, from the stratosphere to the ground. The aircraft, housed with telecommunication equipment, circles the stratosphere. By delivering network connectivity, HAPS can create a wide communication area about 200 kilometers in diameter. The area can overlay existing areas covered by terrestrial base stations. Devices in urban areas where network traffic is heavy can preferentially connect to base stations. Devices in rural areas where network traffic is light can connect to HAPS. It allows operators to optimize their communication networks by region. HAPS is a potential communication solution for areas that cannot be reached by base stations. It can also meet the needs of future services that use IoT and other technologies. HAPS is designed to enable the coexistence of multiple networks, so one aircraft can be utilized by different telecommunication carriers at the same time. Since it flies in the stratosphere, HAPS is disaster resilient. If a ground gateway is damaged in a disaster, HAPS connected to a working ground gateway can relay network coverage to an affected area. Furthermore, mobile networks delivered by HAPS, such as 5G, are highly secure. This means it can be applied to public services provided by administrations and local governments that need to be highly secure. Additionally, by switching equipment in the aircraft, HAPS can serve purposes other than mobile communication. This versatility means it can adapt to future technologies. The future that HAPSMobile envisions is just around the corner.
All right, let me continue the presentation. So to accomplish the HAPS visions, we have established the HAPSMobile. So we have been working for this project for last 3.5 years, since 2017. And then some people may think, this is kind of a dream or vision or still concept, but this is not the concept. Actually, we have already completed aircraft, the very first version in 2019. So this is the actual picture of the aircraft that we have built in 2019. And as you can see, this is real. So please, watch another video. Hope it's going to work this time. And then you can see the actual flights and the actual aircraft within that video.
HAPSMobile uses an aircraft equipped with a mobile base station that is designed to fly for several months. Using lightweight carbon materials, it can fly even with little wind. With a total wingspan of about 78 meters, it can also withstand turbulence. The wings house solar panels, while the aircraft is equipped with high-performance batteries. During the day, the aircraft flies, while solar panels charge the batteries. During the night, the aircraft continues to fly off the charged batteries. The aircraft does not use any fossil fuels, making it completely sustainable. Given these technologies, we predicted the aircraft could fly for 24 hours, and that is why we started the HAPS business. The onboard computer automatically controls the aircraft according to wind patterns. The simple wing-based design improves aerodynamic performance and also makes mass production possible. During takeoff, the aircraft follows guidance from the Airport Takeoff and Landing Center. It flies in circles to increase its altitude. When it reaches the stratosphere, a globally managed operation system directs the aircraft to a specific service location. Once it arrives at its service location, the aircraft flies continuously on autopilot for several months, delivering internet connectivity to the ground. The aircraft's design makes it possible to switch or replace systems as necessary. This makes it compatible with LTE, 5G, and all other types of base stations. The aircraft can also house sensors and cameras. In 2019, 2 years after we started the design process, the aircraft cleared NASA's safety review tests and succeeded in its first flight. The aircraft will soon be flying in different parts of the world. A connected world is right around the corner.
And we did a flight test over the night. And then not only the flight test, we installed the payload that is provided by Loon, and we actually did a communication test using a Zoom. So the picture you are seeing right now here is the pictures we took when we did a test and when we were doing the video streaming test between Japan and the US. And we have confirmed, couple tens megabit per second for the long downlink, and it was very smooth, and we were very happy to see that. And towards the commercialization, we are targeting for commercialization in 2023. The countries that we can provide a service is going to be limited, but we are targeting in commercialization in 2023, which is coming in next 2 to 3 years. So again, we're not talking about a dream, we're not talking about the concept, but we're talking about actual commercializations. This is a real. However, we cannot make it happen just by ourselves. We need to have a company. We need to have lots of friends to make it happen. So we made a HAPS alliance. We founded a HAPS alliance to make this happen. To make it a commercialization. And we do have a big partnership and an alliance with the Loon. And jointly we founded the HAPS alliance. And through the HAPS alliance, the purpose is, as you can see at the right-hand side, it's a cross-industry collaboration. HAPS is composed of the aircraft, the regulation, the spectrum, payload, many things. So you need to have the cooperation from the varieties of the industry. And second one is to accelerate commercial adoptions. So, for example, when you want to have a commercialization in certain countries, you need to pass the order test. So we need to have a local partnership in that specific country. And the third one is safety regulatory regulations. When you want to fly the aircraft, you need to pass all the regulations, and we need to have a lot of cooperation to make it happen. And the fourth one is that have leadership and educations. HAPS is not still well known, so we need to people we need to educate. So through the within the HAPS alliance, we have 3 working groups: telecom working group, aviation working group, and a marketing working group. And now we're thinking to expand the working group as we grow. So through the each working group, we are collecting all the partnerships and trying to make a de facto standard. As I say, this is gonna be the first challenge for us, and we cannot make it happen just by ourselves. So we need a cooperation. So we within this working group, we're gonna make a de facto standard as an industry. We have around the 20 more than 20 companies join within the HAPS Alliance today, including the Loon. And if you are really interested in to join HAPS Alliance, please visit the URL or please just read the QR code so that you can access to our website and then you can join. And just for now, you can have the general members, first year. So first year will be free if you want to join the general members. So again, HAPSMobile, through HAPSMobile or HAPS, we want to eliminate all the data divide in the global, and we want to bring the connectivity and the internet to all the people. And I'd like to pass it to Henry from Loon. Henry?
Yeah, thank you very much, Hidebumi, for the presentation and for everything you've been sharing about HAPSMobile. Very excited to be here with you today and to talk a little bit more about Loon and how we've been partnering together with HAPSMobile over the past few months. I wanted to start with telling you a little bit more about when Loon started to work in the stratosphere. That was about 8 years ago. At the time, there were not a lot of things happening in the stratosphere. It was mostly some scientific experiments. There were some supersonic jets flying in the stratosphere, but not many large-scale initiatives. We had mastered space for quite some time with satellites that have been orbiting in space for more than 50 years, but the stratosphere has been considered as a very hard territory to master for a very long time. Over the past few years, things have started to change. Loon and others have been able to prove that it was actually possible to build and to imagine and to conceive basically platforms that could work in the stratosphere and provide service over a long period of time in a sustainable way for people on the ground. As Loon has been working on that, we started to meet with other companies that were sharing the same type of vision and the same type of ambitions. That has been the case with HAPSMobile. And as we've been meeting with these companies, we started to think about how we could partner together to enable that new industry basically that could happen in the stratosphere. We've published a white paper earlier this year that you can actually download from our website, and you can use the QR code that you can see on this slide over there, and you can see how we consider that it's possible to imagine a new industry in the stratosphere. When you think about Loon, it's not necessarily only about the solution that we have end-to-end with our balloon-based vehicles and the network that we deploy on the ground. It's also a full stack of things that we've been developing and that actually could be reused by other companies trying to develop projects in the stratosphere. That can be the case for the software that we've developed that help orchestrate our network or that help all our vehicles to navigate autonomously in the stratosphere. That can be true for some of the network components that we've been developing, especially for a network on the ground, or that can also be true for the radio components that we've been developing to work in the stratosphere. And actually, the partnership that we've had with HAPSMobile is a great illustration of that. When HAPSMobile came to us a few months ago and we started to engage about what we were trying to develop and what the HAPSMobile team was trying to develop as well, we thought that actually what we had developed for our own vehicles that have been flying in the stratosphere for a few years could actually be adapted to their vehicle and to be fitted there and see if it could work. The conditions that you experiment in the stratosphere are very different to what you see on the ground in terms of the constraints you have in terms of mass, thermal environment, weight as well that you can carry on the payload. All these are very different constraints that you have to deal with. So you cannot really use off-the-shelf equipment. You have to develop a specific type of radio equipment that can work in these conditions. So what we started to work on, a team of Loon engineers has been working on trying to fit a Loon radio payload onto the HAPSMobile fixed-wing vehicle. So you can see on this picture a Loon team trying to do that and adapting the payload onto the HAPSMobile vehicle. It was a great success actually to see that we were able to fix the payload, launch it in the stratosphere a few weeks ago, and then conduct a few successful broadband tests, as Hidebumi was sharing before. This has been a huge success, and the ability to demonstrate that it was possible to have that payload fitted on other vehicles. And that's also something that is important because as we develop a stack that can work in the stratosphere, it's fundamental to make sure that we end up with a solution that can be interoperable and standard across different platforms, which is ultimately something that's going to help more mobile operators to adopt HAPS solutions. The other aspect to that, and Hidebumi has been talking about it before, is the creation of the HAPS Alliance. As we're trying to build that new industry, there are a lot of things that needs to be thought about so that the conditions are met to enable that new industry and the new companies that want to succeed in that space to be able to operate. There are simple things like the way you coordinate, for example, with air traffic controller that has been working on for many years with aircrafts. And now when you're thinking about a platform that's going to stay in the air for hundreds of days, it's a very different type of framework that has to be set with air traffic controller. So if you want to be able to do that properly, you need to be able to engage with other companies that are trying to solve the same problem so that you can come up with the same story and engage the right way with the regulators. So that's one of the objectives that we have within the HAPS Alliance. Another thing is to make sure that we are building solutions that are adapted to mobile network operators that are going to help them solve challenges that they have to provide coverage in hard to reach areas. And so in order to do that, we also want to make sure that we have the mobile network operators fully on board and fully involved in that process so that we end up with something that is really solving the challenge. So that's why we've been regrouping leaders from the industry, whether it is like aerospace companies, network system companies or telecommunication companies, to basically think about like what are the things that needs to happen in order to create the right conditions for that new industry to emerge. So that's how that's the genesis basically behind the HAPS Alliance. So these were just a few thoughts I wanted to share about Loon and about how we've been partnering with HAPSMobile. I will hand over to Justin, and I think we can take a few questions now. Yeah.
Yes, thank you very much, Henri. Good to hear how the Loon project fits in to the wider HAPS ecosystem. Thank you very much for your thoughts. As Henri said, we do have some time now for Q&A. I've been watching lots of very good questions coming in from our audience during the last 30 or so minutes. So thank you very much for asking all those questions. There is still time to ask a question. So if you did have any other thoughts, there's a box underneath the slide presentation. Insert your question and we'll do our best to cover it. So let's try and get through as many questions as possible in the next 10 or 15 minutes. Going to start with one of our viewers asks a question about the test flight that HAPS carried out last month or so. I know there was a press release about this last week, Hidebumi. And one of our viewers says, have you had time yet to think about any initial learnings from the test flight that was conducted last month? Have you evaluated it? What have you learned? Anything you can shed some light on there, Hidebumi?
Yes. First of all, we found a confidence. Our beliefs became confidence. That is a big things that we made. But so we spent last 3 years to design and to execute this flight test. And actually, we have done 4 times flight test, for the aircraft. But last month, that was the first time we achieved the stratosphere. And it was big challenging. But when we succeeded landing, our beliefs became confidence. But we found, besides that, we found a lot of things and learned a lot of things. And there are many items that needs to be fixed. We cannot that much detail, but for the aircraft, we need to change the design based on the data logs that we get from the aircraft test. And for the payload test, for example, for the propagation test, we had something expected result, and compared with that result, we needed to modify some configuration parameters. So that there are a couple of things that we need to fix, but step by step we're moving toward to the commercialization, obviously.
Thanks, Hidebumi. I have another question for you as well. Gentleman Mohammed Fahim Momen, who's from the operator Robi Axiata. He's the general manager for Robi Axiata in Asia. Mohammed asks, one very pertinent question is, how do your aircrafts work in coordination with other aircrafts, all of which, of course, will be crossing the sky? How do you ensure that there's obviously no interaction, no physical interaction between between your aircraft and I guess commercial aircraft as well? What can you offer us in terms of insight there?
So actually, this is now the kind of the pilot stage. So we need to do the coordination or arrangement with all the players. So that we need to make sure there's no flight during that time of the period, and then after we confirm, we're gonna do the flight test. But when it comes to the commercialization, we're gonna fly like a couple thousand of flights, so that it is not possible to control, by manually if we can fly or not. So we are researching and trying to develop, kind of automatic control system when it comes to the commercialization. So to your question for the pilot, we do our arrangement and make sure there's no flight during that period.
Thank you, Hidebumi. Henri, be interested to get your thoughts on that as well. Obviously, yours is a very different type of aircraft, if you like, given that it's a balloon. What can you offer our viewers as well in terms of how Loon works with other aircraft in the sky? Is that a big challenge for you?
It's definitely something that is extremely important. So it's been a few years that we've been working very closely with the FAA, with the air traffic controller as well. In every country where we operate, we always want to make sure that our operations are safe. So the coordination is extremely important. Loon is flying at an altitude of 60,000 feet, which is way above the commercial air traffic. That being said, every time we enter into an airspace or we exit the airspace, we always coordinate with air traffic controller to let them know what we're doing in the airspace, for how long we're planning to stay. And this is particularly important for two reasons. Number one is we have flights that are, and it will be the same also for fixed-wing drones in the future. We have flights that are very different to the way air traffic controller normally operates. In theory, you have an aircraft that's going to go from point A to point B for a flight that's going to last for a few hours. In our case, we have flights that are going to last for many weeks or many months, staying in the same area. So that's a completely different type of work that the air traffic controllers have to do, and the way they need to handle our type of flight. So that's a big coordination that we have to do with them, educating them on how our vehicles are working. And then the other aspect is obviously when a Loon vehicle is landing, we bring it to the place where we want to land the vehicle, and then we basically coordinate with the air traffic controller during that period of time, during which we're going to have to cross basically commercial air traffic as we're landing our vehicle. So we always do that in coordination, so that we make sure that we don't go across like a commercial air traffic path, basically. So that's how we do the coordination. Yeah.
Thanks, Henri. Hidebumi, we've had quite a few questions kind of looking at the longer term plans for HAPS. Obviously, this has got people quite excited. You've started the testing and you've talked about commercial launches in the next few years. Question from Jeremy Taylor, who works for WTBTS. Jeremy asks if you could provide a bit of background or color on which continents are priority for you in terms of receiving service from HAPSMobile, and then also adds how many aircrafts will be launched by 2035. So obviously that's probably a difficult question to answer. It's 15 years away. But can you give us a little bit of insight into where you might be offering service first in terms of global coverage, please?
Yeah. So, it's going to be step by step, maybe a couple of steps to cover all the global. So again, it's driven by clean power. It's all solar powers. So you need to have a big power from the sun. if you are close to the equator, you get more power. So the first countries or first continent that we are targeting for is those areas that close to equator, maybe plus minus 15, 1.5. And we for the next step too, we're going to equator plus minus 30 and plus minus 50. So maybe and then in next 10 years we're gonna have all the global coverage. And for the second question, how many flights we're gonna have in 2035? I cannot answer the exact number, obviously, but again, our vision is to eliminate and provide a connectivity and the internet to all the people. That means we have to provide this service to all the people in the global. So there should not be this divide. That means we have to provide to all the global markets. So in the term, maybe it's gonna be a couple thousand flights should be on the air.
Thank you, Hidebumi. Thanks for that. Question directed at Henri. Henri, Shiv Pucha, who's the founder and principal analyst at Mandela Insights, he notes that you mentioned during your presentation, Henri, that operating in the stratosphere requires special radios. Shiv asks, can you elaborate on this? What are some specific differences and who makes these radios as well? Could you just comment a little bit more on the radios that are required, please?
Yeah, sure. So I'm not the radio expert within Loon, so please forgive me in case I'm not giving like all the very specific technical details. There are mostly like three elements. Number one is the mass basically that we have in terms of the constraints. So obviously we have to carry that radio in the stratosphere. So we are very constrained in terms of what's the maximum weight we can carry. So we have to optimize that as much as possible so that we have something that is light, but that can still operate with the right amount of power. The second constraint that we have is in terms of power, basically. So making sure that we have, because we're all solar powered, as also Hidebumi was mentioning before, we need to make sure it's properly optimized because we have this limited amount of power available while we are flying, which is very different to when you're connected to the power grid. The third criteria is the thermal environment. So when you operate in the stratosphere, you have a very thin air, which means that you cannot use the same type of cooling principles that you would use when you're on the ground. Like, for example, a fan would not work the same way at all. So you need to use different cooling principle, and you still have very important variation of temperatures. It can go down to minus 90 degrees, but then it can go up also significantly, still in the minus. But like you have these huge variations that you have to handle with different cooling principles. So that is something that has definitely that is causing some stretch on the equipment. So you need to design it in the proper way. And then the last element is we all obviously want to make sure that we have a radio that is working with regular handsets, which is something that is also extremely important. So we have to design this radio so that it can also work with at the long distance. So we fly at 60,000 feet, so that's roughly 20 kilometers. So we need to make sure that we're able to design a radio that enclose the downlink and the uplink at this distance and still even like expand the coverage. So that also requires some important changes. That being said, we always make sure that we are following 3GPP standard basically, so that again we have something that works in a standard fashion. In the case of Loon, we've been co-developing our radio with Nokia in order to make sure that we have something that could really be adopted and working as smoothly as possible for the mobile network operators that are partnering with Loon, basically. So that's how we've been approaching it. So I hope I clarified a little bit some of the different constraints we have to deal with when we design our radios for the stratosphere.
Thanks, Henri. You also touched on a few areas that we'd had other questions for as well. In fact, a couple of viewers had they'd actually asked about the devices and whether they were going to need to buy new phones to support HAPS. From what you've said, it doesn't sound like that is going to be the case. Is that correct?
Yeah, no specific devices. Basically, the Loon radio system is designed in a way that your standard LT device today is working with the Loon system. And actually, with the mobile network operators that we're working with and that are currently rolling out the Loon service, they're doing it in a transparent way so that if you're on the ground and you're connecting to a network, you might not be able to know if you're connected to the terrestrial network of the mobile network operator or if you're connected to their stratospheric network that they're rolling out with Loon, because it's completely transparent. So you on your phone, you don't see the difference if you're connected through a Loon network or through a terrestrial network, and definitely a standard device is a standard LTE device is working on Loon. Yeah.
Thanks for clarifying, Henri. Good to know. Hidebumi, if I could ask you a couple of questions. Gentleman called Izzet Saglam, who works for operator Turkcell. He had a couple of questions. Maybe we can cover them. Mr. Saglam asks, if I use your HAPS solution, will there be interference with the terrestrial network? He also asks as well, do you plan to connect HAPS with LEO satellites? Maybe we can take the first question, which was about whether or not there was any potential for interference with terrestrial networks. Do you envisage any concern around there?
Okay, let me answer the first question. To avoid interference, of course, if you use the exact same spectrum as the terrestrial network uses, the interference is going to happen. So we need to avoid the interference. To do that, we are assuming, to use the dedicated spectrum that is only for the HAPSMobile. And to make it happen, we need to communicate with the MNO locally or the government. But basically what we are doing is to talk to the MNO and then ask them to allocate the dedicated band for the HAPSMobile so that we can avoid interference. But if that is not possible and you need to collocate with the existing spectrum, we're gonna do the cell design and the simulation how that HAPSMobile radio transmitting affects the terrestrial network or vice versa. So either way, we're going to avoid the interference, but the best case will be use the dedicated spectrum. And the second question, I will use the LEO satellite for the HAPS. Yes and no. I mean, that is one of the research items that we are working on it. But rather than that, we are prioritizing inter-HAPS backhaul, so that one gateway can support the couple of the HAPSMobile HAPS aircraft, and between the HAPS aircraft, it does communicate through the millimeter wave or dedicated spectrum. That way, you can reduce the number of gateways, and for example, you can fly over the sea where the land doesn't exist. Of course, LEO satellite or maybe GEO satellite is one of the options, but you need to consider about the payload. Of course, if you want to install the satellite devices or CPEs, you need to install on the aircraft, which is going to be much heavier. So that is it's going to be a little bit challenging. But we are looking for varieties of the option to make this happen. I hope that answers the question.
Thanks, Hidebumi. I have another question for you, if I may. Gentleman called Todd Beals. Todd works for Canadian operator TELUS. Todd asks, what happens to the station after 6 months? Because you obviously talked about the station being active for around 6 months. What happens to it after that, Hidebumi?
Okay. Actually, technically, you can fly 1 year, more than 1 year, or maybe 2 years. But for the maintenance purpose, we are programming the operation manner. When one aircraft landed, another aircraft goes up. But 24 hours, 7 days a week. That's the service availability that we need to provide to the MNO and the end users. So all the time, 2 aircraft are on the sky and for the redundancy purpose. So to your question, if after the half year, that aircraft lands and for the maintenance purpose, and after that it goes fly again.
Thanks, Hidebumi. got a question. It's kind of a broad question, but I think it would be good if both Hidebumi and Henri could offer their take on this. One of our viewers says, what are the biggest barriers that need to be overcome to make HAPS a success? Obviously, this is a very ambitious initiative, Hidebumi. You've made good progress so far, but what do you see as the biggest challenges and the biggest barriers coming your way over the next few months and years, please?
Yeah. So to do that, of course, we need to have alliance. We need to have a cooperation. But to make much easier, we founded HAPSMobile. That is one of the purpose. And through the HAPSMobile, we want to make this de facto standard within that industry. So to your question, having lots of companies and players, alliance, that is the kind of necessary things to make this successful.
Thanks, Hidebumi. Henri, I'd be interested just to hear if you have any other input to that as well. You're obviously playing a strong role in the HAPS Alliance too. What do you see, Henri, as some of the biggest barriers that you've got in the next couple of years?
Yeah, so to complement what Hidebumi was sharing, I think there's mostly three things that we need to solve basically to make it real. Number one is the economic viability. So for mobile network operators to roll out the HAPS service and to use them for their coverage, it needs to be economically viable. So it needs to make sense for them to do it. So it means that they can absorb the cost and still generate enough revenue with their subscribers on the ground. So I think that's the number one criteria. The second aspect is the technical barriers. So we've made great progress on that over the past few years. Hidebumi just listed a few other things we have to go through. I think that's something that is also extremely important, is to make sure that we continue to make progress on that and to demonstrate that we can deliver a service from the stratosphere that is like a carrier grade, basically, and that's something that they can really rely on in order to serve their subscribers in the future. And then the last aspect is something that we talked about before, which is the regulatory environment and making sure that we're able to have regulatory frameworks, both from a telecommunication perspective and from an overflight perspective, that are properly framed so that HAPS can succeed. I shared an example before around what it takes to adapt the mindset when it comes to overfly. There are also some things that need to be adjusted on the telecommunication front as well to make sure that we enable this new layer of connectivity. So that's mostly the three things that we need to work on in order to make sure that we are building that new industry in the stratosphere, and that's the entire purpose of the HAPS Alliance, actually. Yeah.
Thanks, Henri. And just on that note, actually, just before I close out, we did get a couple of viewers actually ask how they would go about finding out more information about joining the HAPS Alliance. I don't know if Henri or Hidebumi, perhaps Hidebumi, you take that one. Glenn Jones, who's the managing director of Tau Tech UK Limited, he had a specific question about joining. What's the best next step if anybody watching wants to take part, please?
Well, it's very simple. Just Google the HAPS Alliance. You can find a website of the HAPSMobile and the HAPS Alliance, and that directs you to the joining the HAPS Alliance, and you can choose the membership. And if you have any question, you can ask me, or you can ask a question through the forum through the website. Please free to ask anything.
Thank you, Hidebumi. Unfortunately, we are coming up to the top of the hour, so we'll have to close up there. We did get a lot of great questions. I'm conscious, unfortunately, we haven't had the time to get through as many as we would have hoped, given we had so many questions. But Hidebumi and Henri will receive those questions, and I'll encourage them to follow up with you personally, because it was great to see a great deal of interaction. So thank you very much for all of your questions. Also, if you missed any of today's webinar, we will be making a replay available within the next 24 hours. So please check out www.mobileworldlive.com and you'll be able to catch up with a on-demand replay of this particular webinar. So with that, thank you very much for watching. Thank you, of course, to our speakers, and we will see you all again very soon. Thanks for taking part. Enjoy the rest of your day. Thank you.